Hi everyone. This is our discrete structures project called Temporal and Category-Based Price Similarity Network Analysis. It was prepared by Zishan Azim, accompanied by Sharjeel Ali Khan and Abdul Kabir. Our goal was simple. The normal CPI only shows average inflation, but it hides how prices behave differently city to city. So we used graph theory, specifically similarity matrices, networks, and Hasse diagrams, to reveal patterns that traditional CPI cannot. Our pipeline has 4 steps. First step was to load real CPI-type price data from Pakistan. Second step was to convert it into city product price vectors. Third step was to compute cosine similarity between cities and build networks using a threshold value tau. Fourth step was to calculate degree, closeness, betweenness, and eigenvector centralities, and then rank the cities. We implemented everything inside a custom class called CPI Project. This class is responsible for building similarity matrices, constructing category-wise graphs, computing centralities, and generating rankings. We also built an interactive dashboard using Matplotlib so users can change tau and weighting schemes live. Here are some of the most interesting results from analysis. First, this heat map shows how similar cities are based on food prices. Clusters appear clearly. Next, the network graph shows strong similarity edges. Node size represents city centrality. And here is the Hasse diagram, showing how the similarity network evolves over years, which is deeply tied to our discrete structures topic on partial orders and transitive reduction. Finally, here is the final city ranking, combining all categories. These visuals reveal something powerful. Some cities consistently remain similar across categories, forming stable clusters. Others diverge, showing different price dynamics. Central cities in the network act as benchmarks, meaning their price patterns represent the national trend more accurately. This analysis is far more detailed than traditional CPI and shows how graph theory and discrete structures can uncover hidden relationships in economic data. Before wrapping up, here's a quick review of how the entire system works behind the scenes. My code begins by converting Pakistan's CPI dataset into structured city product price vectors using pivot tables. These vectors are normalized and passed into a cosine similarity function, which measures how similarly each city behaves in its price patterns. Using a threshold value tau, the code then builds a complete network graph for every category and every year, connecting only those city pairs whose similarity is strong enough. Next, the system computes 4 major graph-theoretic centralities: degree, closeness, betweenness, and eigenvector centrality. These are combined using either equal weights or dynamically computed weights using correlation and entropy to create a final score for each city. Finally, all these results are visualized through Hasse diagrams, similarity networks, heat maps, and a final ranking chart, helping us understand the temporal price relationships in a clear and mathematical way. Here is our complete code, all implemented using Python and discrete structures concepts. Here is the result of our code. To conclude, our project combines real-world economics with discrete structures concepts, graphs, partial orders, centrality, and similarity functions to create a powerful analytical tool. This project was developed by me, Zishan Azim, with my teammates Sharjeel Ali Khan and Abdul Kabir. Thank you for watching. If you want to explore our code or results, feel free to reach out.